All right, we are starting Unit 3, Biochemistry. Let's start it off by talking about what is chemistry and what are the basics that we have to know before getting into this unit. The first question is, what is matter? You've probably heard of matter in the past, especially middle school, but it's anything that has mass and volume. So it's anything you can touch, everything that makes up living things and non-living things. It's kind of the foundation of everything in the world and the universe. And this matter comes in four different states or forms. It can be a solid, which all the material inside is very close together and it's densely packed, we say, so it seems hard. It can be a liquid, where they're a little less connected, all the material inside this form of matter. So it tends to flow and fill up whatever container you put it in. There's gas, which seems to almost have no limits. It can expand as big as it wants to. And these particles are not really, this material isn't really associated with its neighbors at all. It's not stuck to them in any way most of the time, so they're free to float wherever they'd like. The last one that you may not have heard of before is plasma. It's essentially a gas that's had electrons passed through it. Now, all of this matter is made of what we call atoms. So, what is an atom? An atom is the smallest particle of matter, so it's the smallest that anything can get and still keep all of its original characteristics. There are things that are smaller than atoms, and we're just about to talk about them, but they don't have the same characteristics as whatever atom we were talking about as the original stuff that it came from. We discovered them by asking the question, if we keep taking a material and hitting it and breaking it in half over and over, what's the smallest piece that we could break before it stopped being a rock or air or something like that? Now, atoms are made of three things: protons, neutrons, and electrons. A proton is just a positive particle found inside what we call the nucleus. Next to it, inside this nucleus, are neutral particles. They don't have any charge at all. They're not positive or negative. Now, I said they're found inside the nucleus. What is that? Well, it's just this very dense center material with a lot of mass or weight inside of it. It contains almost all of the weight found inside an atom. And this is the defining part of the atom. And we'll talk about that more in a second. Electrons are negatively charged particles, so they have the opposite charge of the proton. But they're not found inside the nucleus. They're found outside of the nucleus, moving around in their own special pathway. So all of these different types of atoms have their own special characteristics and properties, and we call those elements. Elements are just pure substances that can't be broken down into any other kind of substance. They are their pure original form. They are the things that will mix with other stuff, other elements, to make different materials, and we'll talk about that in the next slide. So the type of element you have is defined by how many protons you have in your nucleus. So oxygen is one of our elements, and it always has 8 protons in its nucleus. It will never have 7, it will never have 9. If it had 7, we'd call it nitrogen. If it had 9, we would call it fluorine. The number is the defining point. Now, these elements are not the only thing that we find in the world. These elements have this really cool ability to be able to mix with each other in very unique and different forms, and they create these mixtures that we call compounds. So these are just mixtures of elements that have an entirely new set of properties than their original material. So one really good example: hydrogen is a gas, so it's floating around in the air. Same with oxygen. But when we take 2 hydrogen atoms and we combine it with one oxygen atom, we create what we call H2O, or water, which is a liquid. It has a very different set of properties than the original materials. So water is not an element because it's made of many different elements. We call it a compound. Another name for a compound is a molecule. So you'll hear me use these terms interchangeably, but as we go on through this unit, we're going to probably use molecule a little bit more. Now, another example of a compound. If I take carbon, which is the same thing in the tip of your pencil, it's the same thing you can find in diamonds, and if you take oxygen and hydrogen from the air, you can turn that into something called glucose, and that's what plants make during photosynthesis. It's a special sugar that helps them grow. It helps them get all their energy. So building on that, when we make these compounds and molecules, we call that process a chemical reaction because they're elements that react on a chemical level, not just on a physical level. We're not just cutting it in half. We're actually turning it into something completely different. So chemical reactions occur when two or more elements share or exchange electrons or even transfer them over to each other. And when they do this, they can interact kind of like different Lego pieces fitting together or puzzle pieces fitting together to create entirely new substances. So the materials that go into the reaction are called the reactants. The way I remember this one is the reactants want to react. The materials made at the end are called the products. So your finished product is what you get at the very end of all your hard work. So using the photosynthesis example, carbon dioxide and water are what we call reactants. They are combined using energy from the sun to make glucose, or sugar, and oxygen. You've probably heard about this before in your previous science classes. So carbon dioxide and water are the reactants. They want to react. And we produce the products, sugar and oxygen. Now, I've been saying properties and characteristics a lot. What exactly do I mean by that? It's basically just the defining attributes of whatever we are talking about, whatever substance we're looking at, whether it's a compound or an element. So your physical properties are often related to your senses. What do you see about it? What can you touch or feel about it? So color is an example of a physical property. You can have something have a property called luster, which is how shiny it is. How does it reflect the light? You see this a lot in minerals and metals. And then another one that's kind of interesting is flammability. This isn't a physical property, this is a chemical property. Will it go through a chemical reaction? But the ability of something to catch fire is very specific to different elements or compounds. Not everything catches fire, or not everything catches fire easily. Everything has in the world its own properties, its own characteristics, and this is all based on that atom. How many protons do you have? How many neutrons do you have? How many electrons? All of that is going in to saying what are the properties of your atom. The electrons are often involved in chemical things, so they will tell us how we're going to react with something else. Neutrons are often talked about when we discuss radiation and radioactivity. And the protons, that's actually the defining part of our element, as I said before. So why do we need to know all of this? Why is it important for us to go into the land of chemistry when we're talking about biology? Well, in this particular unit, we're going to be talking a lot about 4 different molecules, 4 different compounds that are found inside every living thing interacting with each other in the environment, and they make us who we are. On top of that, everything is made of atoms and elements, including us. Every single part of our body is some combination of different atoms. Also, The only reason why we're able to move or breathe or talk or even sleep is because there's chemical reactions happening in our body, giving us energy or moving our body and allowing us to do all of these things. We're even going to talk about special items inside our body, special molecules that will let us speed up reactions so that we can do things that otherwise wouldn't normally happen in nature. It's pretty cool. Now, when I said that we're made of atoms, we have to go back to our levels of organization. Remember, we talked about how is the world organized. We have the biosphere at the top, then ecosystems, then communities, populations, and then the individual or the organism level. I'm sorry, and I missed biomes in between biosphere and ecosystems. But there's actually organization below that level too. So if we start at the organism level, right underneath that we have an organ system. So you've heard of like your circulatory system or your nervous system. Those are many different organs working together for a common cause. So the next step down from organ system is an organ itself, like the heart or the kidney or the brain. It's something that has a very specific function inside your body. But organs are made of tissues or groups of certain types of cells. So tissues are made of cells. That's going to be our whole next unit. We're going to learn about cells, and for the next few units, we're actually going to talk about how they divide and reproduce themselves, how they get energy, how they move things in and out. It's pretty interesting stuff. But if we zoom in even farther, we can see that there's things inside of our cell here. Those are called organelles, little organs. So it's almost like think of your cell as a whole new organism, and it's got its own little organs inside of it. Well, these organelles are made of molecules. We have two different types that we're really going to focus on, even though they're all essentially the same thing. They're all molecules, but one special group we call macromolecules. It just means that they're really big. And at the very bottom of it all is our atom. Like I said, it's the base unit of matter. Everything that has mass and volume is going to be made of these atoms. All right, so that is all I have for this lecture. It was a shorter one. So make sure that you review all of your vocab terms and write those down. And I will see you guys next class.